I was thinking about the next few videos I was going to make, and I realised that in certainly a couple of them I wanted to do some performance comparisons. And in order to do that, you also need some kind of tool to measure the performance of whatever code you're writing. Now obviously you can do that sort of thing for yourself by using datetime.now and getting the start time and the end time, subtracting them. But in terms of statistical analysis and that sort of thing, it's not going to be very good unless you put a lot of effort in which case that's lots more code. And in fact, there are third-party libraries available to do this. And so the one that I'm going to be looking at, which is quite a widely used one, seems pretty good to me, is one called BenchmarkDotNet. So this week, I'm not going to be focusing on what it is we're actually doing the benchmarking on, but just on the tool so that we can see how it works and use it in future videos. So that's what I've got. So what I've created is simply a console application. So this is .NET 6, basic console application we've got there. And just to get things going, I've created a couple of classes called Dynamic Concatenations and Fixed Concatenations. And also I've added on some unit tests. Again, one set of tests for each of those classes. And we'll see in a moment why those are useful. But other than that, those classes are all pretty much empty, and the tests are at the moment just got a creation test to make sure everything's working. First thing to do is to add the actual benchmark Nuget package. So we'll go to this benchmarking, this is the console application, do manage Nuget packages, and then we'll browse for benchmark, and that's the one we want, BenchmarkDotNet. So we'll click on that and install it. And that will get us that library installed. We can see in there a link to the URL for the project. I'll put that up in the comment section as well, because I'm only going to be looking at the basics of it. There's lots and lots of other features, and in terms of documentation, you'll need to look in the documentation there. But having done that, what we can now do is start writing some code. So what I'm going to actually do benchmarking comparisons of is the way that we can add strings together in C#. There's always been something since right back at the beginning of C# where there have been certain things to watch out for if you get this wrong that can be rather unconformant. So what I'm going to do in this class, notice this has to be a public class for it to be used for these benchmarking tests, but I'm going to put in here a few properties. I'm going to have an int called x and a y and a z, and let's initialize those to equal 1, 2 and 3, and then I'm going to put in the first method that I want to test the performance of. So I'm going to have a public again, and it's going to return a string, and let's call this simply using plus. So I'm going to concatenate some strings simply using the plus operator that's built into C#. And so I'm going to say return, and then we're going to say x equals, and then plus x plus, and then full stop, space, y equals, and then plus y, and then again, full stop, space, z equals, plus z, plus, and then a final full stop on the end there. Okay, so we're simply going to print out x equals 1 dot y equals 2 dot z equals 3. Few things to notice there. Probably the most important one is the fact that I'm actually returning that. You might think it would be a good idea simply to say something like that, so just form up the string and have it as a local variable. But that hits on one of the problems that you'll have to watch out for in lots of places with benchmarking, the fact that the optimizer in the compiler may spot that your code is just too trivial and remove it. So since that variable x is never going anywhere, can't be sure exactly what the optimizer will do, but it may not make any use of it. So it's generally a good idea to make sure you return whatever it is you're doing the work on for the benchmarking, because the optimizer therefore can't make any guesses about it. And so that's what we've got there. And then to make this something we're going to measure, we simply need to put on there the attribute benchmark, which we get from the namespace that comes with the library we just installed, so benchmark.net.attributes. And then that will be run when we run the benchmark. So in many ways, the way we do benchmarking is somewhat like the way we do unit testing. So you might have an attribute of fact with an X unit to do a test. We have this attribute of benchmark. There are a lot of differences. They're not the same sort of thing. Most importantly, benchmarking is something you only do on occasional bits of code that you're worried about the performance of, whereas unit testing you should be doing a very high level of code coverage. But we've put that first benchmark in there, and then to get that to run, all we need to do is go to our program. We can get rid of that hello world. And then we simply on here say benchmark runner. Again, get the namespace. And then dot run. And then the various ways we can use this, but the way I'm going to use it is as a generic for the class that contains the benchmark that we just put in there. So that's going to be fixed concatenations. And again, get the namespace for that. One last thing we've got to watch out for is the fact we need to do a release build of this, because obviously when you're doing benchmarking, you want it to be on the most optimal build you can have. So we do it on a release build. If you do it with a debug build, it warns you that the results aren't going to be as reflective as they should be. And then once done that, we simply run that. Again, run it no debug, so we don't want the debugger attached. And you can see, because it's a console application, it pops up the console and starts doing some work. And what we'll see is this actually takes quite a long time to do all of its setup and its comparisons and its various runs. Because what it does is it doesn't just run that bit of code once, it runs it a number of times. It actually determines dynamically by default how many times it's going to run it by looking at the standard deviation of the results and waiting till it's run it often enough that those are fairly small. And then in the end, we'll see some results like this. So in future, during this video, I will cut those delays just so we're not wasting time watching it churn through. But in the end, you'll get something looking like this. Gives you a summary of things like what my processor is and that sort of thing. And then we can see that that using plus method took an average time of 45 and a bit nanoseconds, and then you can see an error and also a standard deviation. So you can see what variation we had from that. And pretty simple, just one example there, and it gives you a quick explanation of what's going on. Lots of configurable features in all of this, one of which is the fact that we can choose different columns. Those are just the default ones we get. We'll see some of those later on, but it depends what you're interested in. For the most part, I think the mean is the most important one. The standard deviation, if it's particularly large, might be telling you something odd about what's going on. I mentioned that it calculates the number of iterations it's going to do based on it honing in on an accurate result. We can take some control over that. So what I could do is on the class that I've got that benchmark in, I could put an attribute on here, and I could actually very precisely say how many iterations I wanted to do, but the attribute I'm going to use is just a predefined one, short run job, and that will basically mean it now goes for a small number of iterations, but it will run a little bit quicker, and so this should go through quicker, which may be something you want to do if you're trying to just get a feel for things, but ultimately I think the longer one is better. One other thing to mention while this is churning through, obviously you've got to be careful you're not really doing anything else on your machine, because that will have an effect on the results. And we can see there that it said it's done this short run job and that it's only done 3 iterations. So that's much quicker, but we're not going to have as much accuracy in the results. So now let's move on from there and actually start comparing different ways of doing this same job of concatenating those fragments together into a string, because that's what we want to compare. So what we'll do, as well as the using plus, I'm going to have a using interpolation. And so that is going to be actually the one that I would normally do, because I think it's the easiest one to read, but obviously that doesn't mean it's going to be the fastest one to perform. So we put $1 on there, and I'm just going to say x equals, and then x, y equals y, z equals z. So certainly much nicer in terms of writing it and reading it. But there are other ways of doing this as well. Before string interpolation came along, we used to have to use a thing called string.format. So using format, and then on this one we would say string.format, and then we have to put in placeholders, so 0 and 1 and 2. And then after that, we put the things to fill them in, so X and Y and Z. And then the other one that we can use, which generally is suggested to be the fastest, is to use a string builder. So if we put that in there, so using builder, and then in that case, what I'd be doing is saying something like this, var builder equals new string builder, and then builder dot append, and then on that one I'm going to start with my x equals, and then let's pop in a few of those. So then I'm going to append x, then I'm going to say dot space y equals, and then I'm going to put on y, and then I'm going to say dot space z equals, and then one more, and I just put on z, and then just return builder.toString. So those are 4 ways of doing it. Now I've put benchmark on all of those, and what that will mean is we get results giving us the time in typically nanoseconds. It could be microseconds if it was taking a long time, but sometimes that can be a bit difficult to compare those numbers. So something else we can do is we can make one of these what's known as a baseline, and then we can see the performance of the others as a proportion of the baseline rather than as raw numbers of nanoseconds. And the one I'm going to go for, obviously it's up to you, but that's going to be the one I've got here, where we can have benchmark and then we simply on there as a parameter say baseline equals and then true to turn it on. And so that will mean that one is the one the others are all compared to. Now, I mentioned right back at the beginning that I'd added unit tests to this because one of the easiest mistakes I find you can make when you're trying to do comparisons for benchmarking is you don't actually get the code to do the same thing. And so they all end up doing slightly different things, and you might therefore have invalid results. And so that's why I tend to like to put unit tests in, because what we can do is go to our fixed concatenation tests, and what I'm going to do is put in a private const string, which I'll call result, and that's going to be what the expected result should be. So it should be x equals 1 dot y equals 2 dot z equals 3 dot, and then I can simply put in a fact for each one of the possibilities. So we're going to have one for the plus, and I'm simply going to say assert dot equal the result that I just created there, and then the actual, which is going to be new fixed concatenations dot using plus. And then if I just duplicate that, then we're going to have one using interpolation, one using format, and the last one using builder. And so that just means that we can check they are all ultimately doing the same thing, and we haven't made any silly mistakes that would make the comparisons invalid. So if we go to the test explorer there and run that, we can see that I have made some mistakes. And in fact, I've got it wrong 3 times out of 4, which just shows how rubbish I am. So if we look at that one, that case, I've missed off something in the builder. So if we go to the builder, I'll put that in quotes. We also had a problem with the format. Format, that one, I've missed off the space. I've got something wrong in interpolation. That one I've missed off a space as well. Rerun the tests. Still got something wrong. Builder, I've missed off the trailing dot. So you can see, although those little differences aren't going to make a huge difference to performance, they could mean your tests are invalid. And obviously, a more serious mistake could mean your tests were very much invalid. So now we've got them all doing the same thing, at least we're on a level playing field. One other thing I'll do in there as well actually is just remove that short run job just so we can see the more valid results. So if we now run that up, and this is going to take much longer because we've got 4 functions that we're testing now, plus we've removed that short run job. So I'll skip through this and we'll just look at the results. And so there we can see we've got those results now. So we've got the 4 methods, it lists the 4 methods. Because I put in that baseline, it's also got the ratio, both of the mean and of the standard deviation. And you can see, so 1.0 is on interpolation because I set that one as the baseline. And you can see, perhaps surprisingly, that actually using the plus in that case is slightly quicker than using interpolation. And also you can see that using the builder is slightly slower, and that using the format, string.format, is actually substantially slower. And that actually is the one that, when I first doing this sort of thing, surprises me. I'd always assumed that interpolation was just kind of layered on top of string.format, but it's using a different mechanism and it is somewhat more efficient, as we can see. But the fact that plus is actually fastest is a bit of a surprise. The reason, remember, that using plus for concatenation is frowned upon is that every time we do one of these operations, so when I say that bit, that creates a string with the value x equals 1, and then onto the end of that string is added the next one, so that will be x equals 1 dot y equals, and then onto the end of that we add that, so it has to build it up step by step. So here we've got 1, 2, 3, 4, 5, 6, 7 individual strings, and so to put them all together it actually has to build another 6 intermediate strings before you get the final one with everything added together. And that's a lot of creation and storage and that sort of thing that can slow things down. So you'd probably find if this were a bit longer it would be slower. But again, this comes back to the other thing we've always got to be aware of when we're doing baselining and performance comparisons, that if you use simple examples, then the compiler may be doing its own optimizations, which actually spoil what you're doing and make it not representative of a real application. So the main thing to do is actually benchmark code that's as close as possible to what your application is really doing and not really do what I'm doing here, which is have simple examples. But I can just show you the slightly less optimized way and we'll see there's a difference, because if I add another one of these called using plus equals, and then what I'm going to do here is say var str equals, and then let's just begin with what we've got there. And then I'm going to say str plus equals, and then copy and paste. So we're going to say plus equals x, and then we're going to say plus equals that lot, plus equals y, plus equals all of that, plus equals that, and then finally return str. Let's put in another test just to make sure I got that all right. So plus equals, and run the tests. All working. So now when we run it, we can compare those results. And so now we can see that it's got all 5 of those, and the using plus equals is a fair bit slower than the using plus, and therefore also slower than the using interpolation. So it's difficult to know exactly what was happening there in terms of the optimization, but there was some pretty powerful optimization it could do with the plus that it wasn't able to do with the plus equals. And so that's why you want to do things as close as possible to the code you're actually going to be writing. Now, I mentioned that the reason that just using plus or indeed plus equals is sometimes inefficient is because it has to do a lot more memory allocation for each of those substrings that's building up. And in fact, we can do something within this .NET benchmark to actually have a look at what's happening in terms of the memory. So if we go back to our actual class, because what I can do on the class again is I can add another attribute, which is memory diagnoser. There's actually a number of these for adding diagnosis of different system resources. Again, if you look at the documentation, you'll see what else is there. But the memory one is a nice one. So if we run that up, and then if we take a look at that, we can see that it's added a couple more columns. It's the Gen 0 and the allocated, and it explains in the legend. So the Gen 0 is telling us how many Generation 0 collections there have been on the heap. If you're not familiar with the way that the .NET garbage collector works, I did a video on a while back. I'll put a link up just to explain what that is. But generally speaking, that number, if it's smaller, you're probably running more efficiently. And then also we can see the amount of memory that's been allocated. And you can see actually in this one, the interpolation has the lowest memory usage, and we can see the figures for the other ones as well. So that can be useful in explaining why the performance is low, or just other issues about worrying about using too much memory. So far, we've just been looking at the results as they're displayed in the console when it comes up. if you want to be sharing that data with your colleagues or doing some further analysis, you can get hold of it by other means. So if we just go into the File Explorer and drill down into .NET 6, and then here we've got this BenchmarkDotNet artifacts, and then into results, and you can see that each time we do a run, it gives us these various ways of looking at it. So we've got an HTML. So if I open that up, just drag that over, then you can see it's giving us that basic data, but displayed in a slightly neater tabular way with the same information. We've also got, you saw there, a CSV, and then also we've got a MD, so a markdown document. So you're getting it stored permanently as well as just having it displayed to you in the console. And indeed, when we look at those results, as I've said, it's perhaps a bit surprising that the using plus is coming out fastest. But the essential reason for it is we've actually got very small amounts of data. So we're only taking those three numbers and concatenating them together with some other text in between. And therefore the overheads, particularly of something like the string builder, which we can see down here, are quite large for the one-off creation of the string builder compared with the simpler approach of just using the plus. If we were putting more things together, then it would start to get more significant. And the thing is, when we're using most of these techniques, certainly when we're doing things like the string interpolation or the format, then we've got a fixed number of things that are going in there that is fixed at compile time. So I can't really make that dynamically add a variable number of bits and pieces together. Whereas using something like the plus equals or using the string builder, we could be getting data from an array or something like that and building up really large pieces of text, which you'd probably see the performance differences better anyway. And so that's what I've got this dynamic concatenations for, because what I'm going to do in there is compare the plus equals and the string builder using large numbers of data. So what I'm going to do in here is I'm going to have a property in here that I'll have an int called count, and then I'll have a public string called plus equals, and I'll make that a benchmark again. And then what I'm going to do on here is I'm going to say var result equals empty string, and then I'm going to say for int I equals 0, I is less than count, I plus plus, and then on there I'm just going to say result plus equals I plus space. Okay, and then we just return result. So that will be using what we expect to be slower, and then let's do the same sort of thing. But in this one, I'm going to use builder. So I'm going to say var result equals new string builder. And then I'm going to say result dot append I dot append space. And then, of course, return result dot toString. And then I'm going to do my test because I want to make sure these are doing the same thing. So in my dynamic concatenations tests, let's just do, let's call this check. And then what I'm going to do is say var concat equals new dynamic concatenations. And then I'm going to say concat dot count equals, and let's say make that 10. And then on here, I'm going to say assert dot equal, and I'm just going to compare the two results. So concat dot plus equals compared with concat dot builder. Now, in terms of unit testing, that really is something you'd probably frown upon because you want to be comparing a fixed known result against the result of the class under test. But here, I think, because we're not really doing unit testing on production code, we are doing a test on our performance test. I think that's a reasonable thing to do, just as a quick way to check that we're getting the same result. And so if we run that, and we can see that that's worked fine. So we don't have any problems about them doing different things. So if we just go back into there, one thing I want to do, I think the builder is normally the better way to go. So I'm going to make that one our baseline. But then the other thing we've got to watch out for is this count. We've got to set that up somehow. Now, I could have done it by just putting a value in there, something like that. But that would mean we could only test for that one value. It would always be the same. You could put a default constructor on these, but you can't put any kind of overloaded constructor, so that's not a way to go. You can have a setup method, so I could have a public void setup to say something like count equals 10, and I could label that one with the attribute global setup, and then that's run automatically by BenchmarkDotNet to set things up. But in fact, the best one I think we've got here is I can actually put another attribute on the property itself called params. So that's an attribute again coming from this library, and then I can list multiple values that I want to look at. So I can put on there the parameters that I want this to be run with. So let's go for 1, 2, 3, 4, and 5. And so what will happen there is that the runner will actually run each of those two benchmarks, the plus equals and the builder, 5 times using each of those different count values. So we've got a lot of different benchmarks running now, and using that we should be able to see the crossover where it switches from the simple plus equals being more efficient than the string builder to being less efficient, which we'd expect with larger numbers. And then the last thing I'll do, I'll just pop on here again. Let's have that memory Diagnoser so that we can see the extra information. And then the very last thing I've got to do is remember, if you go back to our program, we were running the fixed concatenations class, so I now need to change that to the dynamic concatenations so that we're running the right thing. And so now if we run that up, this one's going to take a really long time because we're running those tests 5 times, those different values. So we'll zip to the end. And so now a very long time later, we've got the results and we can see it's separated those out. So we can now see the name of the method plus the count value 1, 2, 3, 4, 5. And if we start looking at those, then we can see that for one iteration, you've got the advantage is with the plus equals, almost equal, but still slight advantage to the plus equals on the 2 iterations. But then after that, 3, 4, 5, increasingly you can see that the string builder is having an advantage over the string concatenation. So if you're doing this for a large number, then it would start to really give you an advantage of using the string builder. But that was it for BenchmarkDotNet. There's lots more features in there, all sorts of things you can do. You can specify, for example, which version of the .NET runtime it's going to be running the tests on. You can set it up to take in command line parameters rather than having to configure things in code each time. So if you have a look at the documentation, you'll see more on that. But I just want to look at the basics because in the next couple of videos, we're going to be using that to actually compare some other features of .NET and C# and see how they work. So hope you tune in for those. But if you like that, do click like, do subscribe, and I'll see you for the next video.